This video is about differentiation and how to sketch curves, quadratic curves and cubic curves. We'll start working backwards really by looking at a curve and figuring out what the key points are and then how to get those key points. So first of all, the shape of this quadratic curve, you'll notice that it crosses the y-axis once, crosses the x-axis twice, and it has a turning point. So we need to find all of these key points. So this point here where the curve crosses the y-axis, the corresponding x value is 0. So therefore we sub in x to be 0 into our curve and we figure out what the y-intercept is. 0, 10 in this case. For these 2 points here, where the curve crosses the x-axis, we want to figure out what are the x values whenever y is equal to 0. So then, because the curve is y is equal to x squared minus 7x plus 10, let that equal to 0, factorize and solve, or use your formula and solve the 2 coordinates where it cuts the x-axis, therefore are 2, 0 and 5, 0. And the last point is the turning point. So turning points are found by letting the gradient equal to 0, therefore differentiate and let that equal to 0. The x value is therefore 3.5. We want the y value as well, so plug this 3.5 back into our original equation of the curve and we get the turning point to be 3.5 and minus 2.25. But we need to find out if that's a maximum or a minimum, so we do the second derivative. And because the second derivative gives a positive answer, that's a smiley face, that means that that is a minimum. So these are the key points that help us to sketch this curve. So let's look at an example from scratch. The quadratic curve we want to sketch is y is equal to x squared minus 6x plus 8. So going by the key points, we need to know where does it cut the y-axis. So let x is equal to 0. 0 squared minus 6 zeros, add 8. We get a coordinate of 0, 8. That's where it cuts the y-axis. It's going to cross the x-axis whenever y is equal to 0, so we let the equation be equal to 0. So then we can factorize and solve. Our 2 coordinates are 2, 0 and 4, 0. And then there's one more coordinate we need to find out, that's a turning point. So differentiate and let it equal to 0. When we differentiate, we get 2x minus 6. Therefore our x coordinate of the turning point is 3. Plug that back into our original equation to get the corresponding y coordinate. Therefore the turning point is at 3 minus 1. Now we have all the points, but we still need to find out if that turning point is a maximum or a minimum. So the second derivative of our equation of the curve gives a positive answer, which means that this is a minimum turning point. So sketching the curve, we have these 4 coordinates, 0, 8 where it crosses the y-axis, 2, 0 and 4, 0 where it crosses the x-axis, and 3 minus 1, which is the lowest point of our curve. So here is where it cuts the y-axis, 0, 8. There's the 2 points, 2, 0 and 4, 0 where it cuts the x-axis. This is our turning point. The second example is a cubic curve, and there's more work to a cubic curve. Start off the same though. Where does it cut the y-axis? Just let x equal 0, plug x as 0 into this, you'll get 0, 0. So it crosses the x-axis at the origin. Now to find where it cuts the x-axis, let y is equal to 0, and in this particular example, this cubic example, we can factorize by taking out a common term. We can take out x. Now what that means is x multiplied by a bracket is 0. X can be 0. One of the solutions is x is 0. So therefore 0, 0, we already know that anyway, but 0, 0 is one of the coordinates where it cuts the x-axis. Now we have this quadratic as well, so we need to solve that quadratic to get the remaining 2 coordinates where it cuts the x-axis. This quadratic can't be factorized. We'll use the formula and we'll get these coordinates. The coordinates where it cuts the x-axis are minus 3.62 and 6.62. So we have altogether in this cubic curve 3 coordinates where it cuts the x-axis because of the shape of the curve. We also need to find not 1 but 2 turning points. So there's a video on finding the turning points on a cubic and on quadratics if you want to watch that first. But what you need to do is differentiate and let dy by dx equal to 0. In this case, the quadratic can be divided through by 3 and we get 2 solutions. There's 2 x values that give the 2 turning points. We also want the y values, so plug these back into our original equation. These are the 2 coordinates of the turning points. but we need to know if they are the max or the min turning points. One is the max and one is the min. So our second derivative, we're going to plug in our two x coordinates. So taking this coordinate minus 252, the x coordinate is minus 2, plug that into our second derivative gives a negative answer, which means that this is our our maximum turning point. Plugging our x value of 4 into our second derivative gives a positive answer, which means that that is the minimum turning point. So our key points here: cuts the y-axis at 0, 0, cuts the x-axis 0, 0 obviously, and these 2 points, the turning points are here, where the maximum is minus 252 and the minimum is 4 minus 80. And the sketch, using all those points, here are the 3 points where it cuts the x-axis, cuts the y-axis at the origin also. Here is our turning point, the maximum turning point, and here's the minimum turning point.